Good day everyone. Now I'm showing you how to build a Arduino based multimeter. So I have here the example that I have built. So first this is the Arduino, the LCD, the potentiometer, the do you call this a capacitor, polarized capacitor, and a power supply. Now we have these cables wires here connected to each. You can I can paste the file in this channel below and its code. So let's start. So first things first, we connect the ground and 5 volts here, and then connect to the top and connect here, and then connect to the other breadboard. So then the power supply connect here, then from here to the resistor, then to the resistor, the other side of the resistor, then connects to the A0 pin. Okay, and then this capacitor connects these to the, from here to this line, and then to the pin A3. Okay, and then the A1 is connected here. So here is the pin. Oh, I'm sorry. Here is the pin and connect to the volt and the ground. So the pin 2 is ca- the res- the pin A2 is connected to the resistor. Then the resistor has to connect to the ground, and then to the other resistor, and then to voltage. Let's change the color red. Okay, and then this is the other potentiometer, so connects to the volt. Okay, to the voltage from here to pin to LED anode. Okay, so we have here the I can because I have a limited time. So let's go to the codes. Okay, so first things first, we have include liquid crystal H. So liquid crystal H, LCD is 12, 11, 4, 5, 6, 7. So the voltage and the current reading variables. Int sensor value equals to 0, then and float. Okay, and float voltage input to 0.0. Next, float voltage reading is equal to 0.0 volt. Current reading 0.0. Float RA is equals to 15,000 milliseconds. Point 0. Float float RB is equals to 1,500 milliseconds. Point 0. Okay. Now we can have to resistance the reading variables. Int analog pin OHM is equals to A2, pin A2, that's what that is here, and then int row is equals to 0, int v v in is equals to 5, which is the 5 volts here. I'm sorry, and v out is equals to 0, which is the ground. The float R1 is equals to 1000 milliseconds, float R2 is equals to 0, then float buffer is equals to 0. Int analog pen is equals to 3. Okay, from here int charge pin is equals to 13. The charge, the discharge pin is 10, and int resistor or value is 10,000 ohms. I'm sorry for that. Uh, unsigned long start time, unsigned long elapsed time, float microfarads, and float nanofarads. So let's go to the void loop. Let's go to the void setup. LCD begin at 16. 2. Pin mode A1 is equals to in, pin mode A1 input LCD dot clear. Okay, then let's go for the loop. Void loop int sensor value is equals to analog read or A1 serial dot println sensor value delay 10. Voltage input if sensor value is lesser or equal than 255, then set LCD that set cursor is 0 to 0, then LCD print voltage. LCD the set cursor is 0 to 1. LCD print voltage reading. LCD print V, current output. Else if sensor value is greater than 255 and sensor value is less lesser or equal than 510. LED that set cursor is 0 to 0. LCD that print is equal to current. LCD that set cursor 01. LCD that print current reading. LCD print MA. So let's go to capacitor output. Else if sensor value is greater than 510 and sensor value is lesser or equals than 765. So charge pin mode, charge pin, uh, that comma output, digital write, charge pin low, serial that begin 900 9600, digital write, charge pin and high. So this indicates that begins charging the capacitor. Start time is equals to millisecond. Begins the timer. While while analog read analog the pin is lesser than 648. Oh, then we have the elapsed time. Millisecond is equals to millisecond minus start time. Microfarads float elapsed time over divided by resistor value times 1000. Serial.print elapsed time serial.print ms. LCD.set cursor is 00. LCD.print capacitance. LCD.set cursor 01. LCD print elapsed time. LCD print ms. If microfarads is greater than 1, this determines if units should be micro or nano and prints accordingly. So serial.print long microfarads, serial print microfarads. LCD that set cursor 51, LCD print microfarads, LCD print UF. Else nanofarads is equals to microfarads times 1000. Serial that input long nanofarads, serial that print ln nanofarads. LCD that set cursor 7 to 1. LCD prints I 7 and 1. LCD print nanofarads. LCD print NF. Digital write, charge pin low. Pin mode, discharge pin output. Digital write, discharge pin low, while analog read times the analog band is greater than 0. So let's have pin mode, discharge pin input. Prevents a capacitor from discharging. Now let's go to the resistor output. Else, rho is equals to analog read, analog pin OHM, um, if rho buffer is equals to rho times V in and V out is equals to buffer divided by or over 1023. Buffer is equals to V in and V divided by V out times -1. So R1 is R2 is equals to R1 times the buffer. LCD set cursor 0 and 0. LCD dot print resistance. LCD dot set cursor 0 and 1. LCD print R2. LCD print OHM delay 1000 milliseconds. So the voltage and the current reading. Voltage input analog read A0, which is here. The analog, this is the pin A0. Okay, I'm sorry for that. Okay, so voltage input analog read pin A0 times 5.0 divided by 1023. Voltage reading, voltage input divided by RB divided by RA plus RB. Okay, current reading is equals to 1000 times the voltage reading divided by RA plus RB. Okay, let's simulate this. All right. See, let's close the code. Let's just change the volt here. Okay. See, capacitance. Okay. And that's all for this video. Thank you.